Hey there, everyone. So yeah, obviously I'm not here today, but your supply teacher has played you this lesson. So we're going to start ahead with our last unit. It's only 3 lessons, so it's going to be quick. And overall, it's easy. It should mostly be review, okay? So we're going to be talking about volume and surface area of different 3D shapes. Okay, so first off, let's just talk about what volume is, okay? But don't remember, volume is the amount of space something occupies. So something occupies or something takes up. Okay, so every 3D shape has some kind of space, so they all have volume. Okay, so like a box of the amount of space that you have in a box, or in a can of tuna, or any other 3D shape like a pyramid or anything, they all have volume, so they all take up space. Okay, and remember, the units for volume are always cubes. So it doesn't matter what our units are, whether it's centimeters, meters, feet, inches, kilometers, doesn't matter what it is, it's always going to be that unit with a little 3 at the top to indicate that it's cubed. Okay? So let's talk about volume for different shapes. So first we're going to start with prisms. So prism is a solid with a base and top faces that are congruent, parallel polygons, and all the faces are parallelograms. Okay? It's a long way of saying that it's essentially a box. Okay? So we'll have two of a top, of a base at the bottom. I'm going to draw in there. So the base and the top are the same shape. So this one, they're both squares. They can both be squares, they can both be rectangles. It doesn't matter. Okay? And they're parallel to one another. Okay, so they're not going to run into each other. And all the other faces are rectangles. A rectangular prism is a 3D-dimensional object with opposite faces that are congruent, parallel, rectangle specifically. Okay? So like this one here. Okay? So what's the volume for any prism? So what we have here is this side is our length. The bottom, let's say, is our width. And then the one going up is our height. Okay, so that's the key difference from area to volume. We still have the length and the width, but now we add in the extra dimension, that's why it's 3-dimensional, of height. So the volume for any prism, or really any 3D shape, is one area of the base, to do length times width, times the height. Okay? Or another way of writing it would be my length, L, times width, W, times height. That would be my volume. Okay? So for any kind of prism, it's length times width times height. And I have a formula sheet, which I'll hand out when I get back. That way everyone has it before we get into it. Someone else has it. Okay? Just be a way to either remember or not have to remember what all the formulas are. Okay? So length times width times height. So if we do this example here, a DVD player. You might not remember what DVDs were, but they're a way of like watching movies way back in the day. So it's shaped like a rectangular prism with a length of 45 or 42.5 centimeters, a width of 30 centimeters, and a height of 12.5 centimeters. Now we want to determine the volume of the DVD player. Okay? So our length here, length is 42.5, 42.5 centimeters. My width here, 30 centimeters, and I have a little height, which is 12.5. Okay, so we know that the volume for a prism is the area of the base times the height. The area of the base for any rectangle is always length times width. Okay, so that's why we can simplify our volume formula to length times width, that's the area of my base, times height. Okay, now I'll sub in my numbers. So my length was 42.5 times my width, which is 30.0, times my height, which is 12.5. So we multiply all these on your calculator. Don't try and do it in your head. It'll be a waste of time where your calculator can do it. So you should get 15,937.5 centimeters, and remember, our answers are cubed. Okay? That 3 is important because it represents that it's the volume. Okay? We have a centimeter times a centimeter times a centimeter. We didn't go centimeter times a meter times a mile. Okay? So we want to keep those consistent. That way we have a unit that we can easily quantify. Okay, we go to centimeters squared or meters squared, whatever our units are. It doesn't matter what the units are. This question starts with centimeters, so we do centimeters cubed. Okay. Figure prisms are probably the easiest ones. So now we get into pyramids. Like pyramids in Egypt. Okay. So pyramid is a solid with a polygon base, and all the other faces are triangles. Okay. And the triangles come to a point. Triangles meet at a point at the very top. So pyramid occupies 1/3 the volume of a prism. Okay, so if you were to take 3 pyramids, kind of stack them all together, you can end up having the same volume as a prism. Okay, even if you kind of cut the pyramids and kind of rearrange them, you will be able to make a prism. Okay, since it's 1/3 of the volume of a prism, we still have the area of the base times the height for our prism, but we just multiply that by 1/3. Okay, since it only takes up 1/3 of the volume. So the volume for any, take up the prism, pyramid is 1/3 times the area of the base times the height. Okay, so for base is a rectangle, we'll use length times width. If the area is a square, like we're going to do next, it's just our sides squared. Okay. If you're going too fast, just ask the supply teacher to pause the video. I'm sure they're a very nice person, and they can pause the video for you. Okay, so we want to find the volume for the following pyramids. So we have a square-based pyramid, side and side. So each side is 6 centimeters. 6 centimeters, 6 centimeters. And my height is 8 centimeters. Okay, so the volume of a pyramid is 1/3 times the area of the base times the height. The area of the base, since this is a square, our area is the side length squared. Okay, if you want to do length times width, you can, you'll get the same answer either way. Okay, but I'm going to use this one just to kind of expose you to all the different ways we can calculate the area. Okay, so my volume is 1/3 times my area, which is side squared, times my height. Okay, so that's going to be 1/3 multiplied by my side length, which is 6 squared, times my height, which is 8 centimeters. Again, put this all into your calculator. You'll get 1/3 times 36 times 8, which should leave us with 96 centimeters cubed. Okay, units are always cubed for volume. Don't forget that. Okay, we'll talk about surface area tomorrow, or sorry, Monday. Then we'll be using squared because it's only 2 dimensions. Okay, final page. Last thing we're going to do is the volume of a triangular prism. Okay? So a triangular prism is a three-dimensional object with opposite faces that can group parallel triangles specifically. Okay, so it's like a rectangular prism, but this one is triangles instead. Okay? The formula for finding the volume for any triangular prism is very similar to what we had before with regular prisms. However, so we take the area of our base. So the area of a triangle, remember, is base times height divided by 2. However, we also have to account for what we call the length. Okay? If this is my base, kind of dot in where my height would be. Since we're using height as height here, this long side is going to be my length. So I have base times height times my length, all divided by 2. Okay? So I still have the area times another dimension, which is my length in this case. Okay? So the volume is going to be base times height times length, but divided by 2. Okay? So the tent is in the shape of an equilateral triangular prism. How much space is there inside the tent? Okay, so asking how much space. That is volume, because volume is the amount of space an object occupies. So I'm given my base is 7 feet. I'm given my length is 10 feet. What's my height? I don't know, right? It's not 7 feet because this side is 7 feet and this side is 7 feet. But I don't know what my height is. But if I drop my height on a straight line down like that, we'll see that we have a right angle triangle. That green tent here, each of these sides is 7, 7. This whole side from end to end is also 7. If I do a dotted line straight down, it'll meet the ground at a 90-degree angle, and that is the height that I'm looking for. Okay? I need that height in my equation because it's base times height times length. Okay? But I have a right angle triangle here, right here is a right angle triangle. Okay? So if I take half of half of the base of the triangle, that'll get me to exactly halfway in my tent. So half of 7 is 3.5. So now I have a right angle triangle with 7 as my hypotenuse, h, and 3.5. Okay? So now I can use the Pythagorean theorem, where I have a squared plus b squared. Actually, let's just jump right to the numbers. So I'll have 3.5 let's say first use Pythagorean theorem to find h. Okay? That's what we're doing first. We have 3.5 squared plus my height squared, and that's going to be equal to 7 squared. Okay, because 7 is my hypotenuse. Okay, the h in this case, I'm sorry, doesn't stand for hypotenuse, it stands for height. Okay, so 3.5 squared is 12.25 plus my height squared equals 49. I need to get h squared by itself, so I'll bring over the 12.25 to get h squared all by its lonesome. That's 49 minus 12.25. Or that's equal to 36.75. Now, how do I get from h squared to h. I take the square root, right? Do the square root of 36.75. So my height will end up being, we'll go to one decimal place, it'll be 6.1, and my units are feet. So I got 6.1 feet for my height. So now I can write that my height equals 6.1, and now I can find the volume. All right? So this was step one. I need to find out what my height was. Now step two, gonna be nice and easy. I can find volume. So volume equals base times height times length. Sorry, I forgot to mention this curly L is length. The reason I don't use a regular L and I use like a cursive L is to show that it's L, not 1. Okay? So I forgot to mention that earlier. So base times height times length divided by 2. So my base is 7 times, I just found out that my height is 6.1 times my length is 10, all divided by 2. You put that into our calculators and you should get 427 feet squared. Okay, so that's it for today's lesson. I hope that's mostly review of previous math classes and geometry. So there's going to be a worksheet that the supply teacher will hand out, and then that'll be it for today. So just work on that worksheet, try some of the questions on your own. Just make sure you can get the hang of using volume equation, and that'll be it for today. And we'll see you on Monday. Bye.